question says derive the equilibrium constant Kc of the following hypothetical reaction. A moles of A reacts with B moles of B to afford C moles of C plus D moles of D. R1 shows the rate of forward reaction, R2 shows the rate of backward reaction. So to solve this, we are going to split this reaction into two. A moles of A plus B moles of B reacts to give C moles of C plus D moles of D. This is the forward reaction. So from the law of mass action, the rate of reaction is proportional to the active masses of the reactants. This is the concentration of reactant A raised to power the number of mole, which is the active mass, times concentration of reactant B raised to power the number of mole. This is law of mass action. So when we remove variation sign, we now have R1 equals constant K1 times active mass of A times active mass of B. This is equation 1. So let's produce equation 2 by considering the backward reaction. The backward reaction is where the products C moles of C reacts with D moles of D to give back A moles of A plus B moles of B. So, and this is R2, backward reaction. From law of mass action, R2 is directly proportional to active mass of the reactant. This time around, the reactants are the products. So concentration of C raised to power C times concentration of D raised to power D. So to remove the variation sign, we now have R2 is equals to K2 times C raised to power C times D concentration raised to power D. This is equation 2. Let's bring both equations together. We said that R1 is equals to K1 bracket A raised to power A dot B raised to power B, equation 1. And equation 2 is R2 is equals to K2 times C raised to power C times D raised to power D, equation 2. So we recall that at equilibrium, the rate of forward reaction is equal to the rate of backward reaction at chemical equilibrium. This now implies that equation 1 is the same thing as equation 2. So we now write it down. R1 equals R2. And R1 means K1 brackets A raised to power A dot bracket B raised to power B. This is R1, which is equal to K2 bracket C raised to power C dot bracket D raised to power D. That is at equilibrium. Now, solving the algebra, we can now say that K1 from here divided by K2 from here equals the whole of this, which is bracket C raised to power C dot bracket D raised to power D, all over the whole of this, which is bracket A raised to power A dot bracket D B raised to power B. Having got this, recall that Kc, equilibrium constant of any reaction, is equal to K1 over K2. The ratio of equilibrium constant of forward reaction to equilibrium constant of backward reaction gives you Kc, which is the equilibrium constant of the reversible reaction. So this now implies that replacing K1 over K2 with Kc, we write Kc as C raised to power, let me write it here, Kc will now give us C raised to power C dot D raised to power D divided by A raised to power A dot B raised to power B. And that is the derivation.